For 70,000 years, this volcano was considered dead. Not sleeping, not resting, dead. No eruptions, no warning signs, no reason to look twice. So humanity forgot about it. Then satellites noticed something impossible. The mountain was rising, not violently, not dramatically, just enough to make scientists stop breathing for a moment. Millimeter by millimeter, the ground lifted, like pressure building under a sealed lid. And that's when the fear set in, because the most dangerous volcanoes don't announce themselves with fire. They do it in silence. Sometimes they inhale first. In southeastern Iran sits Mount Taftan, a volcano most people have never heard of, including many scientists. For decades, it was considered a geological relic, a dead mountain, a scar from Earth's distant past. Its last known eruption happened roughly 70,000 years ago. That's long enough for civilizations to rise, fall, and vanish. Long enough for humans to invent farming, writing, cities, and spaceflight, all while Taftan stayed perfectly still, blending into the background of history. So no one worried about it. No one watched it closely. No one expected movement, until satellites noticed something strange. Between July 2023 and May 2024, Taftan's summit rose by about 3.5 inches. That may not sound dramatic, but in geological terms, it's enormous. Mountains don't just lift themselves for no reason, especially not after 70 millennia of silence. Something beneath Taftan is pushing upward. And whatever it is, it's not subtle. When a volcano deforms, scientists usually check two obvious triggers. Earthquakes, shaking can crack rock and let magma move. Heavy rainfall, water can seep underground and increase pressure. But neither happened. No major earthquakes, no unusual storms, no flooding. Which leaves only one explanation: pressure. Gas or magma is building beneath the volcano, forcing the ground upward like air filling a balloon. Except this balloon is made of rock, and rock doesn't stretch forever. It resists until it can't. Scientists estimate the pressure source sits just 1,600 to 2,700 feet below the surface. For a volcano, that's shallow, dangerously shallow. Imagine a sealed soda can sitting on a stove. At first, nothing happens. No sound, no warning. But inside, pressure is building, invisible and relentless. That's exactly what appears to be happening under Taftan. The volcano may not be preparing a lava eruption, and that's what makes it more dangerous. Because instead, it could produce something far more unpredictable. Hollywood volcanoes are dramatic. Lava rivers, fireballs, cities swallowed whole. Reality is sneakier, quieter, and often far more sudden. Taftan's biggest threat isn't lava, it's phreatic explosions. These happen when underground water flashes into steam almost instantly. The expansion is violent, like a pressure cooker detonating with no release valve. No magma has to reach the surface. No warning lava glow. No slow buildup visible to the eye. One moment, the ground looks calm. The next, rocks the size of cars are launched into the air. Superheated steam blasts outward and ash erupts skyward at jet engine speed. Phreatic explosions are chaotic, short notice, and extremely difficult to predict. And Taftan's shallow pressure source puts it squarely in the danger zone. Even if you live thousands of miles away, Taftan matters, because volcanoes don't keep their problems to themselves. When active, Taftan releases sulfur-rich gases, especially sulfur dioxide. These gases travel with the wind, crossing borders without asking permission, lingering long after the eruption itself. Sulfur dioxide can irritate lungs, worsen asthma, degrade air quality, and react in the atmosphere to form particles that block sunlight and cool temperatures. That cooling effect might sound harmless, even helpful, but on a large scale, it can disrupt weather patterns, alter rainfall, and stress already fragile ecosystems. And if a phreatic blast sends ash high enough, that ash doesn't fall straight down, it spreads. Thin at first, then everywhere. In 2010, a volcano in Iceland, with a name pilots still hate saying, erupted modestly. No global disaster, no mass casualties, yet ash drifted into flight corridors, grounding over 100,000 flights across Europe and the Atlantic. Now imagine a similar ash plume drifting into major air routes over the Middle East and South Asia. Even a small eruption could shut down regional air travel, disrupt cargo and supply chains, and trigger economic ripple effects far from the volcano itself. Volcanic ash doesn't care how small the eruption was. To jet engines, ash is ash. You might assume modern volcanoes are watched constantly. Taftan isn't. It sits in a remote region, difficult and expensive to monitor. And for decades, no one saw the point. An extinct volcano doesn't need sensors, evacuation plans, or hazard maps. That assumption is now officially wrong. Taftan has been reclassified from extinct to dormant. And that single word changes everything. Dormant volcanoes aren't dead. They're waiting. When a volcano is labeled extinct, governments don't plan for it. No evacuation routes, no gas monitoring, no emergency drills. Dormant status forces a reckoning. Now officials must consider sudden steam explosions, ashfall scenarios, toxic gas exposure, and long-term unrest that may unfold slowly, or all at once. And the hardest question of all, what if this isn't temporary? Volcanoes don't follow human timelines. 10 months of uplift might mean nothing. Or it might be the opening act of a new volcanic cycle that lasts decades. What looks like a short-term episode to us could be years of buildup in geological time. Think of the summit rising like Earth inhaling, and when Earth exhales, that's when things get ugly. Right now, Taftan is inhaling. No one knows when or how it will breathe out, and Taftan isn't alone. Around the world, some of Earth's most powerful volcanoes are showing signs of unrest. Not normal volcanoes. Supervolcanoes, they don't erupt often. But when they do, the effects are global. Ash clouds blanket continents. Temperatures drop, crops fail, supply chains collapse. The scariest part isn't just the explosion. It's how little time we might have to react. 12 months of warning might not be enough to feed billions of people, evacuate megacities, or stabilize global systems already under strain. That's why scientists study warning signs obsessively. One of the most closely watched supervolcanoes sits beneath Naples, Italy. Conflagray doesn't look like a volcano. It's a massive caldera filled with cities, roads, ports, and everyday life built on unstable ground. For years, residents have watched streets crack, steam vent from the earth, the harbor rise and sink, and swarms of small earthquakes rattle windows like underground thunder. For decades, scientists assumed this meant magma was rising, but recent research changed that story. In 2023, scientists noticed carbon dioxide emissions skyrocketing to 4,000 to 5,000 tons per day. That usually screams magma movement, except the gas chemistry didn't match. Nitrogen and helium ratios told a different story. The carbon dioxide wasn't coming from magma. It was coming from superheated fluids underground, cooking surrounding rocks and releasing gas on their own. Then, in 2025, lab experiments revealed something else. The earthquakes weren't magma forcing its way upward. They were caused by a sealed underground water steam reservoir. Pressure builds beneath that natural lid. Eventually it cracks. Steam escapes violently, and the ground shakes. That also explains something that puzzled scientists for years. The earthquakes usually start shallow, then move deeper, exactly opposite of what rising magma would do. None of this means Conflagray is suddenly safe. Steam-driven explosions can still blast out rocks, ash, and scorching gas without warning. What's changed is how scientists think about the danger. Watching magma alone isn't enough anymore. Gas, fluids, pressure seals, they all matter. Because if humanity ever gets short notice before a super eruption, we are not ready. Supervolcano eruptions are extremely rare. The last one happened about 26,500 years ago in New Zealand. On average, scientists think a super eruption happens roughly once every 100,000 years. But Earth doesn't follow neat schedules. 2 massive super eruptions shook the planet within the last 100,000 years. About 74,000 years ago, Indonesia's Toba volcano erupted, cooling the planet and possibly pushing early humans to the brink of extinction. Then, around 26,500 years ago, New Zealand's Taupo volcano reshaped entire landscapes. Long, quiet periods don't guarantee safety. They just mean we're between chapters. The real fear isn't that these volcanoes will erupt tomorrow. The fear is uncertainty. Volcanoes don't announce schedules. They don't respect borders. They don't wait until we're ready. Taftan's slow rise is a reminder that Earth is alive beneath our feet, stretching, pressurizing, preparing, and sometimes silence isn't calm, it's restraint. Right now, Taftan is breathing in. Campi Phlegrae is releasing steam, and scientists are racing to understand signals that don't always mean what we think they mean, because when Earth finally exhales, it won't ask if we're ready.